Hi students, welcome you all to ACE Engineering Academy and ACE online platform. Myself Sarvan Kumar, faculty of ACE Engineering Academy. I teach communication systems, signals and systems and network theory here. So today I would like to discuss about some topics that were added for GATE 2027 examination. So I should say these are not extensive topics that were newly added. These are already there in the syllabus, but specially mentioned with certain names, and there are some new topics added in certain subjects. So instead of just telling what are the topics that are added and what are deleted, I would just like to explain you what is the need of these topics in the present era and how you have to focus on these newly added topics. So that is what we are going to focus today. And the examination of GATE 2027 is conducted by IIT Madras. Don't expect the paper to be average or easy. Definitely expect it to be hard. I am not threatening you or I am not creating any fear to you. If you refer the paper set by IIT Madras, GATE papers, you can see the expected questions are above average level only, especially the 2 marks bits. So try to focus more and try to understand the subject. Don't expect the answers to be straightforward. They will be little bit complicated and you have to do more practice. The subject concentration is very important here. It's not that you prepare 9 out of 9 subjects perfectly. Even if you do 5 or 6 subjects perfectly out of your 9 subjects, there is a very good chance for you to get very good ranks this time. Okay, so always the one who are doing this much of preparation, especially coming to a branded organization for your preparation, you should have certain edge among other students. So luck should not play any factor here. It should be complete your hard work only. So try to focus on these points. So with that, let us try to see in each subject what are the topics that were newly added, what is the significance of these topics, and I will not go in depth. I will just touch what are the areas of focus related with these subjects. Why or what is the intention behind adding these topics? Okay, right. Let's start. Now, coming to engineering mathematics. As you already know, this topic has around 13 to 15 marks weightage in GATE examination, and this is the only subject which examiner tells this will be definite weightage. If you see the notification, 13 to 15 marks is allocated for maths. It is written in your notification. That means you should never leave this subject. That is the first point you have to understand. Okay, so that is the most important thing I want to tell you first. Okay, right. Now let us see. These are the topics that were newly added. Under differential equations, they have added non-homogeneous equations. So when you refer to these non-homogeneous equations, generally when you go for a differential equation, you will have linear, first order, multiple order, non-linear, first order, multiple order, homogeneous and non-homogeneous. So when you refer to this particular topic of differential equations, all these are covered very clearly. So there is nothing particularly new related with this topic. So I should say this is the old topic only, or this is not new. Whatever you are studying under the syllabus of differential equation, that remains same. So you need not worry anything about that. Okay. Now coming to correlation and regression analysis, this was added under probability and statistics heading, and this is completely a new topic. So this is a new topic added. So what is there under correlation and regression analysis and why you have to study this topic? I'll just give a brief introduction. I'm not going in depth in any of the topic. This is not a class for you to understand the topic. It's just a understanding of why or what is the background, why they are adding this part. So if you take the correlation part, so whenever you consider, if you remember communication systems, we have random variables and random processes topic there. So under that topic, we have correlation, covariance, correlation coefficient as statistical parameters when you take multiple random variables. So basically this concept is dealing with multiple random variables Multiple random variables basically will be 2 random variables for your examination, and the correlation between the 2 random variables means expectation of product of 2 random variables, and covariance between the 2 random variables means expectation of deviation of the random variable x from its mean and deviation of the random variable y from its mean. Product of these two is covariance, and then we will have correlation coefficient between the 2 random variables. So this correlation coefficient is nothing but this covariance that you are dealing between the 2 random variables divided by sigma x into sigma y. Simple. So it is not necessary for the examiner to explicitly mention this topic. It is already there in your communication systems. But more emphasis is given in probability area. So that is where this topic comes into picture. So it is partially new here. It is not completely new, partially new. Now, one more topic he added is regression analysis. So what is there in this regression analysis? Now, this is a very important topic. Why? What is the significance? So what this regression analysis says is, it's also a statistical parameter. You will have lot of independent parameters and dependent parameters. So how this dependent parameter, whatever the one you are calculating, depends on one or more independent parameters. I will take a simple example. You all are interested in scoring a very good GATE score. Okay. Now, let us assume you want to score some 40 marks. So, this is a dependent random variable, and you want to score by learning certain subjects. Let us assume we have 9 subjects, you are preparing 4 or 5 subjects. That means what is happening? 4 or 5 subjects out of 9 subjects has to be prepared. So, your 40 marks getting GATE score is depending on 4 or 5 independent subjects that are present in your syllabus. So, this is completely statistics. So, which subjects that you are going to study, and by studying which of these subjects, you can score these 40 marks very easily. It's a beautiful mathematical tool. So, basically we use simple line equations to do the analysis of these type of systems. Okay, so this is like y equal to mx plus b, where your y is a dependent variable, your GATE score. I am just assuming one independent random variable x and some intercept or initial value b. So, how closely you are monitoring your score, assuming 3 or 4 or 5 subjects that you are preparing, and how much is your error deviating from your expectation. So, all this study comes under regression. Okay, why it is added? That is also one very important point, right? Simply IITs don't do these things. There will be something behind this. Now, all these are linked directly or indirectly with a broader subject called as machine learning. So, you can see almost all engineering courses, even at BTech level and predominantly at MTech level, are getting added with this particular topic. So, there will be signal processing in MTech, signal processing with machine learning. So, they will use this word machine learning. Why it is very much important and what is its significance today? You can see most of the systems in today's world, you take any type of system, directly or indirectly it is linked with your machine learning concept. Automation is done. So, for this understanding, regression is the basic starting step. So, without knowing this mathematical tool of correlation and regression analysis, you cannot directly enter into machine learning stage. So, to make you focus on this area, this is included. That is the reason why these topics are added in your mathematics subject. So, definitely it's a very important and predominant area. Don't leave these new topics. Chances of getting questions in examination will be more. Okay, so this is what I would like to cover under mathematics part. Okay, hope all the points are clear. Nothing new with respect to differential equations. Under correlation and regression, totally newly added topic. Why it is added also, I am focusing, right? Okay. Let us proceed for the next part. Next part is network theory, network analysis, electric circuits. You may call with different names. The thing is same. There is nothing new, no change. So it is as it is. So the weightage to this topic is around 7 marks to 8 marks in your GATE examination. So this is a weightage given to this particular topic. Okay. I am telling in general weightage, an average of last 4 or 5 year papers. So that remains the same, no change at all. Now coming to the next subject, signals and systems, very important subject. For EC, it's a core subject. So here, first see the removed names. What are the removed names? Discrete time processing of continuous time signals. So what is the actual meaning in that? You are processing a continuous signal by using discrete methods. That means basically you are converting a continuous or an analog signal into a discrete signal for further processing. So what is the process involved in that? Is it sampling or not? That means what are you trying to do here? You are considering a continuous non-periodic and stable signal and trying to convert into a discrete non-periodic stable sequence. So what is the procedure we are following here? Is it sampling or not? So your parameter that you are using here is sampling time or sampling frequency. Finish. And whenever you do sampling of these signals, we are definitely using sampling theorem, because it is a condition which you have to apply for proper sampling so that reconstruction is possible. So it is covered. Now under this sampling process, what are the different types of sampling you have? You are having ideal sampling, where you are using periodic train of impulse pulses for doing the sampling process. And if you use rectangular pulses for sampling, you call it as flat top sampling. Is it correct or not? And whenever you do sampling of these signals, the sampling on signals varieties are, you are having baseband sampling, means you will do the sampling at message signal level, baseband signal sampling. And also you have band pass signal sampling, means sampling after doing a modulation process. So all these are the topics that will be covered under the broad heading of sampling process. Okay, so these are the things that he is now clearly specifying here. So whatever the word that he has removed here has exactly the same meaning that is added here, no change. Nyquist sampling theorem, sampling and reconstruction. That means it includes sampling of baseband signals, sampling of bandpass signals, ideal sampling of signals as well as flat top sampling of signals using sampling theorem inherently. That means these topics are same. There is nothing new in these two topics. I hope my points are very clear here. Okay. Now one more word he has added, FIR and IIR filter design. This used to be there in old GATE syllabus, okay, and it is already present in ESC syllabus. So those students who have already enrolled for ESC batches, they automatically study this topic. For them it is nothing new, but for only GATE students, this is a completely newly added topic. What are FIR filters and what are IIR filters? So as you know, FIR stands for finite impulse response and IIR stands for infinite impulse response. So these are digital filter designs. So when you go for these digital filter designs, you will have FIR and IIR category. So basically why we will study these are pure applications. Whatever you have studied in your signals and systems are applicable in real-time industry. So these come under pure applications. So that is the reason behind including this topic in GATE examination. And I am very clearly telling most important topic of all will be this area. Definitely there is a chance of question coming from this area. So when you refer to these filters, we are having FIR, finite impulse response, and also we are having IIR, infinite impulse response. So when you take these filters, lot of points will be there. So if you consider taking with FIR, these are much stable systems, and these are having linear phase, and most importantly they are used in audio processing. Okay, and when you consider IIR, these are non-linear phase systems, and because of these non-linear phase systems, there are chances that these systems may become unstable, and these are used in various digital transmission applications. Both are equally important. Depending on your requirement, we use these FIR and IR filters. So basically the reason of including this topic is to make you understand about the basic applications with respect to transmission of your data from continuous format to digital format. So whatever the signal you have will first get sampled. That means it will get converted into discrete format. After you get the discrete format, you have the discrete amplitudes. How you are doing a transmission of these amplitudes? So whenever you use a filter, the basic meaning of filter is to consider the frequencies. What frequencies? Sometimes you may have to remove frequencies, sometimes you may have to add some, add means consider frequencies. So whenever you go for filter applications, you are actually extracting or you might be suppressing of certain frequencies. So for that purpose only we use these filters. So depending on your requirement and application, we go for these type of filters. So that is the main reason why examiner is interested in adding this topic. Definitely the most important area. Okay. So these are the things related with the newly added topics coming under signals and systems. And the weightage to this topic is around 9 marks to 10 marks. Very, very important subject. Don't neglect it. And it's a core subject also. And if you are interested in going into IITs or NITs related with communication branches, like you have signal processing, image processing, all these topics are completely related with the fundamental topics of signals and systems only. So you have to be more focused on this area. Okay, right. So I hope I covered all the points. There is nothing new with respect to the first two topics. With respect to FIR and IR, I have already told all the points, right? Now coming to the next subject. So the next subject we are having is electronic devices and circuits. Generally you call it as EDC. So the weightage for this subject in your GATE paper is around 7 marks to 8 marks. I am taking in general weightage. Last 4 or 5 years, if you take and make an average, you can find this average as around 7 to 8 marks. Okay. Now there are nothing topics removed. He is saying about two topics: formation of energy bands in solids and scaling in MOSFETs. Now let us try to understand what these points are. So if you take the first point, formation of energy bands in solids. So whenever you take any solid, basically he is using this word solid. Okay. So whenever you consider solid, you will have atoms. The smallest particle that you have is atoms. Now when normally left open, they don't do anything, but when they are made to interact, interactions will take place. Then they will form lattice structures or crystalline structures. Lattice structures or crystalline structures. Okay, so this is all the fundamental part that you are already studying. There is nothing new here, because when you start the subject of semiconductor theory, from where these originate, you have to understand all these things. So you have atoms, when they start to interact with each other, they form lattice or crystalline structures, and then they form continuous energy bands. So this is all a process. I am just referring to the names in a broader way. So when they form continuous energy bands, what are the continuous energy bands they have? You will have valence band and you will have conduction band and then you will have energy gap, the gap that is there between these two bands. Generally we write it as Eg. Okay. Now based on the structure of these bands, what we are saying, we are dividing them into conductors, insulators, and then semiconductors. I just don't want to make it just theoretical, just saying what are the topics that are added, just to make it little bit clear for you and make it very clear, so that the thing comes into your mind, why it is added. That is most important part here. So if you refer to these points, tell me, all these things are you studying before starting your semiconductor physics or not? Because once a solid is given, you have to consider them either as a conductor, insulator, or a semiconductor. So once the band gap energies are getting mixed with each other, that means there is no band gap at all, it's a conductor. If the band gap is very, very high, it's an insulator. And if the band gap is very limited, that means if you give some external energy, then there is a chance for your charged particles to move from valence band to conduction band and then go for a conduction. That part is what we are calling as a semiconductor. Now, this is where your actual semiconductor theory will start. So this is an introductory part that you will first study before starting the concept of diode. So that is what he is saying here. So there is nothing new in this topic. Relatively, there is nothing new here. So whatever the formation of energy bands in solids that he has specified, the topic that you are studying here is nothing new. It's the same topic that is already studied. Okay. Now, one more word he has used here is scaling of MOSFETs. Now, what do you mean by this? Effectively, what actually examiner wants to test you in this topic. So, MOSFETs you already study. Is it correct or not? So, when you refer to scaling of MOSFETs, what is the meaning? It's very simple. Just try to understand. So, when you take a metal oxide semiconductor field effect transistor, what are the design parameters that you will have? Most of the times you will study about channel length, you will study about channel width, and you will study about oxide layer thickness, semiconductor oxide layer thickness, or parameters related with the oxide layer. So these are the areas that you are focusing on. Now, what do you mean by scaling of MOSFETs? So what is he trying to say here is, he is going for scaling operation. So scaling of MOSFETs means what? Increasing the number, simple meaning. So by what ways he is trying to increase the number? So whenever you are going for scaling of MOSFETs, what is our intention? Our intention is to increase the scalability. Increase number of chips that you are manufacturing per substrate. That is what we call it as a scaling. So with the same machinery available, with the same substrate available, you want to make more number of MOSFETs. So what is the advantage in doing that? By doing this more number of chips per substrate, you are increasing the efficiency or not? Because the total output will definitely increase, and you are also increasing switching speeds. Because obviously when you are decreasing the length of the channel, the time constants whatever you have will also get affected. So it increases in switching, increase in switching speeds or switching times. So you are increasing the efficiency by getting more number of chips constructed for the same available substrate, and you are increasing the switching speeds and reduce in power consumption. So all these are advantages or not? So making a scalability in MOSFETs area. Why he is not talking about scalability of FETs? Because MOSFETs is universal. You can use for many number of applications. So that is the real-time technology that we are right now using. That is also getting changed. Maybe in the next 5-6 years, the technology will get multiplied a lot. So whatever that is right now available, we are trying to increase its efficiency by increasing the number of chips count per substrate. So by doing this, we are getting an advantage on all these factors. So that is the reason why examiner is including this topic here. So those students who are planning to go for VLSI, embedded systems, microelectronics, semiconductor physics in their higher engineering studies of MTech, this is a very important area for them. So instead of getting in touch with these after entering MTech, the examiner is trying to focus on your BTech level itself. Understand the basic minimum concept that is going to come here. So that is the main intention behind adding this subject. And you can see these are the different scaling areas. We are having constant field scaling, where all the parameters which I have told you, that means the thickness, the width and oxide layer thickness, all these are scaled by same factor along with the voltage. So all these are scaled by a constant factor. And when it refers to constant voltage scaling, you will change the parameters of the channel, but you will not change the voltage. So that means you are using the older voltage model with new fabrication technology or new parameters of your chip. And Dennard scaling will be the new technology that is currently going in line with these systems. So these are the areas. So this is all again finally connected with your Moore's law. So what does that law tell? For every 2 years, the size of the chip will get reduced, or in other words, what I can tell is the scalability is doubled. That means for every 2 years, the number of chips that you are encountering or when you are fabricating on a given substrate will increase by 2 times. So that is a level of efficiency that we are achieving in nowadays. So these are the areas that he is trying to focus when dealing with the MOSFET scaling. So indirectly I can say, when you refer to this topic, scaling in MOSFETs, it's related with the fabrication techniques, or little bit of focus is on fabrication area. Okay, so relatively it's a theoretical model, some numericals are also there, but importance is there. So don't remove it from your preparation stage, keep it focused on this area also. Other than this, the other area is already old, there is nothing new in that, but this is a new area. So this is I should say completely new topic, and it has a very good significance also. So you can see here, whenever you focus from BTech to MTech, 2 main domains will come. One will be communication area, one will be the VLSI area. So for that communication area, the fundamental subject of signals and systems is upgraded with that FIR and IR filter design. And for MTech, in terms of VLSI, embedded, fabrication, microelectronics, semiconductor physics, whatever you take, the area related, basic area related with this is fabrication process. So MOSFETs will be the most important area. So the concentration will be on MOSFETs, and how the fabrication of these MOSFETs is taking place in nowadays latest technology, that comes under the scaling of MOSFETs. So that is the reason this is included in your fundamental subject of electronic devices and circuits. So you can see the main intention behind adding these topics. Examiner wants the students to be very clear in their fundamental areas. So depending on their interest, if they want to go into signal processing, image processing, communication areas, the fundamental related with signals and systems is upgraded. And students who are interested in going to VLSI, fabrication, microelectronics, semiconductor physics, the fundamental related with the electronic device and circuits is upgraded. So I don't think the more focus will be on diodes, FETs, all these areas. The primary focus will be based on MOSFETs, how much you are focusing more on this area, the fundamental concepts of MOSFETs, and then how you are applying these fabrication techniques to scale up your business. So that is where these topics are very, very important. Okay, so hope I am making it very clear for you. Don't want to write all the topic names and give you the information why they are actually added. What is the intention behind that? That also I want to make it very clear. Okay, right. Next, with respect to analog circuits, what is the topic that is added? So there is one topic called as a dominant pole, Miller compensation and phase margin. So actually both are one topic only, okay, and they did not remove any topics. So when you refer to this topic, what is this dominant pole, Miller compensation and phase margin, and where actually it fits in? So when you consider these feedback amplifiers, operational amplifiers with feedback. So this is the area where this topic comes under picture. So when you consider feedback amplifiers, you have to work on the stability of these feedback amplifiers. So feedback amplifiers stability, that is where this compensation technique comes into picture. So whenever you have these feedback amplifiers, you have two things. One is the feedback gain, another one is feedback phase margin. So whenever your feedback phase margin or I should say feedback phase tends to 180 degrees, and whenever your feedback loop gain, which you generally write it as A beta, becomes equal to 1 or greater than 1, then your amplifier will be under positive feedback. So you know very well, whenever your amplifier enters into feedback, positive feedback, then it starts to oscillate. So when it starts to oscillate, what is the meaning? It is becoming unstable. So what you have to do? You have to bring it back to stable state. How you will bring it back to stable state? By using this compensation technique. So for these feedback amplifiers, we will use this compensation technique by using pole. Why we are calling it as a dominant pole? Because it's a pole which is very much close to your origin, or you can say the pole which is located at smallest frequency. So by using this dominant pole, we are compensating this phase and loop gain so that the oscillator does not go into positive feedback and it does not become unstable. So that is also a very important area of application. So it directly comes under feedback amplifiers stability. So that is an area that he has included. Is it clear? So this is also a very, very important area that you have to focus on. Dominant pole mirror compensation and phase margin. This is not a new topic. It's a extension area of feedback amplifiers for stability. So I don't think there is nothing new here also. It's a continuation topic of your feedback amplifiers. So nothing new in this topic. You will automatically study this topic for stability concept. Okay. So this is the area in analog circuits, and your analog circuits has a weightage around 10 marks to 12 marks in GATE paper. It's a good weightage. Okay, I hope all the points are clear. Now, coming to the next subject, digital circuits, nothing new, all are same, no change in the syllabus. And weightage for this topic is 8 marks to 10 marks. Digital circuits means it includes computer organization also. So, all put together will be around 10 marks. Nothing new in this area. Next, coming to control systems, he has added one word, PID controllers. So, this is also inherent topic only. What I should say is, whenever you study the entire control systems, basically the control system deals with the stability area. So, whenever you are doing a regulation of a process automatically, then these controllers will be used. That means, it is about a regulation of any system automatically. So, these are done by using controllers. So, more or less I should say it is a applicative area. That is where this actually comes into picture. So, whenever you are designing any system, what is the final important point that we will consider? We will consider the error signal. What is your actual expected output and what is happening in the real time. So, the difference between these two is what we call it as the error signal, which we generally call it as E of t, because it is a function of time, it will keep on changing. So, when you take error signal, you have to have a complete regulation on this error signal. So, error signal may come in live. In live means what? When the system is running current, and these error signals you can understand from the system past behavior, and error signals you can also anticipate with respect to your future behavior. That means here we are considering three very important parameters. You are having a proportional derivative, proportional integrator and proportional constant part. That means when you are dealing with the current stage, current activity or current error, past error and future errors. So, what is our intention? Our intention is to keep this error as small as possible. Ideal case is 0, but it is practically not possible. So, what is our requirement? You have to keep this as small as possible. So, current error diagnosis is done by a parameter Kp, and past error diagnosis is done by using a parameter Ki, and future error diagnosis is done by using constant Kd. Okay, so current error deals with trying to keeping the system with respect to stability in the current operating time. Okay, past error means trying to keep your steady state errors as small as possible. So here the error that you are getting in steady state is minimized, and future errors means you have to keep your peak overshoots as small as possible. Peak overshoot minimized. So, all these three things when you include in a control system, then we call it as a PID controller. Okay, so that is what is dealing with these three parameters. So, your error whatever you are writing instantaneously as a function of time will deal with this Kp, will deal with this Ki, and will deal with this Kd. So, that is the reason we call it as a PID controller. Okay. So, all these three are present. So, whenever you want to do simplification in frequency domain, you will consider this into S plane. Then you are having a homogeneous equation, second order homogeneous equation. So based on that, you are doing the controlling operation. So this is how these things will work out here. So whatever I am telling here is already studied for you, because whenever you are dealing with compensators and controllers, these things are automatically studied at that area. So I should really say that with respect to this added term, there is nothing new here. Already you are studying all these points. So you need not worry about this newly added topic. It is the old one that you are already studying. Okay. So that is about the control system part. And the weightage for this subject is around 7 marks to 9 marks on an average. And very important subject and easy subject. Among all the engineering subjects that you are studying for GATE examination, generally the student interest is maximum in this, because scoring is more. There is no chance for an examiner to give very difficult questions from this subject. So it will be at average level or below average level. So definitely he can score from this area. This and network theory, both are very important subjects for getting you a very good score. Okay. So I hope all these points are clear. Now coming to the next subject, communication systems. So in communication systems, he has added one topic. It is called as source coding. So already we have channel coding. One more area that he has added here is source coding techniques. So when you refer to source coding, that means before doing the transmission, you are using coding there. So whenever you use source coding techniques, the average number of bits per symbols are reduced. That means instead of transmitting some 8 bits per symbol, you will reduce it to 5 bits per symbol. So by using these coding techniques, we are using variable length coding schemes. That is actual meaning here. So when you use variable length coding schemes, the average number of bits that you use per symbol will get reduced. That means effectively your bit rates will get reduced and your bandwidths also will get reduced. So that is the advantage of using these source coding schemes. And we are having two coding schemes. One is a Shannon-Fano coding scheme. And another is Huffman coding scheme. So these are the two coding schemes that we have in this area. And you will have, once you consider this coding scheme on the given symbols and go for a coding process, you have to calculate efficiency of the coding scheme. And then you have to calculate redundancy of the coding scheme. So these are two parameters of these coding schemes. Finish. So this is the only extra topic that is added under communication systems. Relatively, it's a simple area only. It is not complicated. Those who are preparing for ESC, this is already present in that area. So whatever the batches I take in ACE Engineering Academy, I tell this as an extra topic for ESC batches. GATE batches, already channel coding is there. That is a compulsory topic. Along with that, source coding is also added. So I should say this is a newly added topic, but it's a very easy topic. There is nothing complicated, very easy. So no need to focus more on this. Relatively, it is a simple topic. It's not very much complicated. And the weightage in this topic is around 11 marks to 13 marks. That means in the entire communication systems, the weightage for this is at a higher end. If you take the average of all the last 5 years, it is around 11 or 12 marks. So relatively, its weightage is more. So these are the areas that are coming under communication systems. Now, coming to the last one, electromagnetics, there are no newly added topics, nothing new. It's a old syllabus only. Okay, so these are the areas in which some topics are added, and the topics what you have to focus. And slightly I try to tell you why are these topics added also. just like going like a speech. I don't want to tell only the added topics. What is the reason behind adding these topics and how you have to focus very well. So that is the area where you have to focus. Okay. And coming to the dates, the new batches that are going to start. So these are the areas you have to just look on if you are interested. So our classroom batches for GATE 2027, new batches are starting on 20th July. It's the latest batch that has already started. Next batch you are having on 5th August and last batch will be on 24th August. So this will be the last batch. 24th August will be the last batch for those students who are writing 2027 GATE examination. So those who are interested in coming to the classroom and sitting here and studying, please don't waste your time. Make a decision quickly and come quick because the time is running out. So maximum we have 6 months from now on. January and February or January month, you don't take it for sitting in the class and studying. It is completely for revision. So whatever the remaining time we have is right now 6 months only. So try to focus to the maximum extent if you are interested in classroom coaching. And we have 50% discount for our ACE old students. If you are our old students, please make use of it. Okay. Now, other than this, we are also having online live batches. So this is also one program that is continuously going up. And these are the new batches. 20th July, it started just a few days back. Then we have on 5th and 24th August. So these are the last batches that they are going to start. And for all ACE old students, for online program, you are having 25% discount. So if you are interested in sitting in your house, if you don't want to travel, come here, sit here and study, those who are not in Hyderabad, those who cannot travel for more time, more distance, you can make use of these batches. It will be completely live. We will be explaining all the courses very clearly. Okay. So it will be also just the same program as classroom only. Only difference is you will not come here and sit here. That is the only change. But timings will be as per our guidance. So whatever the time we say, you have to attend that time. And you will be supported with all the doubts that you are getting. And the live recording, if you are unable to attend one day, you can have the recorded video. You can just open your app or you can open your laptop wherever you are seeing, and you can just go to the date, go to that video and relook into that video also. That will be available till your course ends. Okay. And apart from this, we are also having a recorded program. So this is self-paced program, pre-recorded video classes. So that means student is unable to come to the classroom. It's not possible for him. And student is not possible to attend live sessions which are conducted by us in our timing. So because I am free from night 5 to 10. So I will ask the student to come in that 5 to 10 interval. So student might not be possible to come during that time, or some people will be working. They cannot come in that time. So for such type of candidates, we are also having a program called as self-paced program. So these are all the recorded live. That means the thing is here, it is not like that when we are taking the class, these are recorded. It's not like that. Separately, we have recorded for this set of students, people. So they can download our app. All the video recordings will be available for them. Whenever they are free, they can just open the app and study. So that is the best feature that you can also utilize. But only thing is, you should have very good discipline. So you have to fix some 2-3 hours per day for that particular study purpose. And whatever the doubts you get, you can post your doubts on our app. We will look into the doubts and reply back to you within 24 hours of time. So it's also a very good program. Only thing is, you have to use your free time effectively, because you are not coming to class and you are not sitting in the time which we are sitting here. So you have to make a discipline so that you will work in that particular time only for this purpose. So open that app and you can go through those videos. Whatever the important points are there, numericals are there, you can work out on that. Any doubts, you can get back to us and we will reply you within 24 hours. So this is also a very useful program. You can make utilization of this program. So there is no like a deadline or time, date, all these things. Whenever you want to enroll, you can enroll for that program. Okay. It's a very effective program. And this year we have also launched a foundation batch for Target 2028. So those students who are currently in second year, second semester, or third year, first semester, these students can enroll for this program. So it's an excellent program for them. The reason behind this is you are having a 1.5 year. If you start from August, say, so this 6 months, next 1 year is there. So 18 months at full dedicated study you can do. So those students who feel they are a little bit slow, or those students who feel that they have to take more time for understanding the basics much more easily, and those students who wants to make master in their BTech curriculum itself, so you can go for this program. And this batch is starting on 5th August. So you can also enroll for this program. There is classroom as well as online also. So whichever the one you want to enroll, you can enroll for this. This is also a very good program, but it's just like a long-term coaching. Okay. So these are the different areas that we are providing coaching. Just make a note of these dates. If you are really interested, you can come with these dates. Okay. So that's it from me. I have explained very clearly, not only focusing on the areas which are included, just focusing on why these are included, so that little bit of understanding will be there for you also. And always be very clear. You make yourself or you train your brain such a way that the paper will be hard only. So if it comes easier, you will be happy. So if you are preparing for a hard paper, paper will look to be easy for you in the examination. So that is how you have to prepare. Okay. So that's it from my side. Thank you and wish you all good luck. All the best.